Dear students, today we are going to see certain terminologies related with Boolean expression or Boolean terms. So, Minterms and Maxterms. Before that, we will see what is a product term. The terms that is connected by the AND operator is known as product term. Similarly, the terms or literals that is connected by the OR operator is known as sum terms. Then what is a minterm? A product term actually it contains all the variables of the function, either in the complemented or uncomplemented form. It is called a minterm because it possesses a value of 1 for only one condition of input variable. So, we will see a little detail. Suppose we are having two variables a and b, two Boolean variables a and b. So, the terms a bar, b bar, a bar, b, a, b bar and a, b, these are the four terms or four combinations that can be had from the two variables a and b. Okay. So, in these four variables, only one variable will give the output 1, that is a, b. All other a bar, b bar, the output is 0, a bar, b, the output is 0, a, b bar, the output is 0. So, only 1 out of 4 will give the output 1, that is why it is called a minterm. Okay. Similarly, we have maxterm. Maxterm is the sum term of two variables or n number of variables. If you are having a two variable, each term is known as a minterm, a plus b, a bar plus b, a plus b bar and a bar plus b bar. Here we know that except a bar plus b bar, all the other terms they will give the output 1, that is why it is called a maxterm. Okay, that is why it is called a maxterm. Then what is meant by canonical expression? An expression which consists of all the variables of a Boolean function. Suppose we are having three variables a, b and c, then any term, okay, that either minterm or maxterm that consists of all the variables a, b and c, then it is called a canonical expression. Okay. For example, if we are having two variables x and y, then xy plus x bar y bar, this is a canonical expression because two terms are there or two literals are there, both are having two variables. Suppose I am writing x plus x bar y bar, x plus x bar y bar, this we cannot see a canonical or we cannot say a canonical expression because the first term x is not x is a single variable term. Okay. So, any number of terms no issue, but the term all the terms should consist of the number of variables that is available in the expression, then we can say it is a canonical. The normal equation is known as a standard equation, and if it consists all the variables in all the terms, then we can say it is a canonical expression. Okay. The canonical expression in terms of minterms as well as maxterms are available. Okay. Now, we will see some examples. Okay. Sum of product term SOP, this is a canonical expression of sum of product. Okay. Sum of product, that is a expression consists of minterms is said to be canonical sum of product term or SOP, that is the terms are connected by the sum operation. Okay. The sum of product SOP, we will see. So, let f is equal to a bar b plus a b bar plus a b, this is a canonical expression. This is a minterm. Why canonical expression? Because it consists of all the terms consist of two variables. Okay. Then why it is a minterm? Because it is the all the variables are in the SOP form. Okay. So, it is a minterm also. Now, we can convert these minterms in shorthand notation or in terms of small m. How it is possible? Please look very carefully. The term a bar b, actually a bar corresponds to 0. Okay. So, for a minterm is concerned, a bar normal our convention is like that, a bar is 0 and a is 1. So here the first term a bar b is the term corresponds to 0 1, which is nothing but 1. So I can give min term, so I have to use a small m, and since 0 1 is nothing but 1, the decimal 1, the first term is m1. Similarly ab bar 1 0, 1 0 is nothing but 2, so m2. Next min term ab, it is 1 1, okay, 1 1 is 3, that is why it is m3. So we are using the term sigma to indicate min terms. Suppose an equation, it is just specified by f is equal to sigma 1 2 3. How we can convert this into the SOP form or sum of product form? So this is nothing but the min terms. Okay. So we are having 3 min terms m1, m2 and m3. So 1 corresponds to 0 1, 2 corresponds to 1 0 and 3 corresponds to 1 1. So this is 0 1 plus 1 0 plus 1 1, or I can write as a bar b plus a b bar plus a b. So if a term is simply expressed by its min terms, sigma m1 2 3, okay, or sigma m1 comma m2 comma m3, or even sigma 1 2 3, then we can convert into the standard canonical form by replacing the value 0 by a bar and 1 by b. Okay, that is 0 in the first place 0 corresponds to a bar, the next place 1 corresponds to b. So 0 1 means a bar b, 1 0 means a b bar, 1 1 means a b. Next is product of sum. The things are just inverted in this case. Okay. So here the product of sum means it is a we have seen that it's max terms. Okay. So we are having a term a plus b into a bar plus b bar. Okay. So this is a product of sum. Here the things you have to notice that a corresponds to 0 and a bar corresponds to 1. Similarly b corresponds to 0, b bar corresponds to 1. Okay. So see here a plus b, it is 0 0. So the term is capital. This is a max term. So m0 is the capital m0, the first max term or 0th max term m0. Then a bar b plus b bar is the 1 1. 1 1 corresponds to m3. Okay. So in max term a corresponds to 0 and a bar corresponds to 1. Okay. So f is equal to m0 into m3. This can be again written as, instead of sigma we have seen for min terms, here we are using pi. Pi stands for the product. So pi 0 3 means 2 max terms, capital M0 and M3, that is a plus b and a bar plus b bar. Okay, the same thing is expressed here. Now for a 3 variable Boolean expression, we can write the min term as well as max terms. Okay. See here the table, the first is 0 0 0. So the min term is of course x bar y bar into z bar, and that is the small m0. But in max term it is x plus y plus z, because x stands for 0 and y stands for 0 and z stands for 0, and it is a max term, that is capital M0. Similarly for all these things you can see that the last one 1 1 1 corresponds to x y z in min term, that is m7 small m7, and x bar plus y bar plus z bar is the capital M7, which is the max term. Okay. Then another example is given where we are asked to write the truth table from the write the output expression from the truth table. Okay. You can see that we are having output to 4 ones in the expression. So these are the min terms m1, m2, m4 and m6, that gives the output 1. So the min term can be written as a bar, b bar, c bar, that is m1 plus m2 plus m4 plus m6. Similarly for the output 1, that the max terms, we have m0, m3, m5 and m7. Or we can generalize that for any type of min term and max terms or the truth table, mj is equal to small mj, that Minterm mj is equal to the complement of the Maxterm m. Okay. So, the Minterm is the complement of the Maxterms. So, here we are having the terms 1, 2, 4 and 6 as the Minterms. Then what are its complements? 0th, 3rd, 5th and 7th terms are the Maxterms. Then how a expression is given which is not in the canonical form? It is given in the standard form. How we have to convert into canonical form? Even for SOP and POS both we can do the operations so that we can convert the term into canonical. See the first example. The example is given like that: a bar b bar c plus a bar b c plus a bar b bar c plus a b c bar. Okay. So, so here the conversion is done from a SOP to POS. Okay. We know that mj is equal to mj capital small mj is equal to capital MJ complement. So, if the Minterms are given, we can write the Maxterms. Next is the conversion. Okay. So, you can see that certain terms are given. The first term, see here, a bar b bar c plus b c bar plus a c bar. So, this expression is not a canonical form, not in the canonical form. It is in the standard form, because here then the second term b c bar we are missing a variable a, and in the third term we are missing a variable b. So, this is not a canonical expression, but it is a, we can say it is a standard expression, but we can convert a standard into canonical and vice versa. Okay. So, see here how to convert this into canonical form. Okay. The previous expression. Okay. First term is of course it is in the canonical form, but the second and third are not there. So, what you have to do is, the first term you add a plus a bar. Okay. Because a is missing, but a plus a bar is 1. So, if you are putting an a plus a bar, it will not change the value of the expression. Similarly, in the third we can put b plus b bar. Then what to do is, you have to expand, and similar terms have to be replaced by one term. If more than one term, same term repeats, you can eliminate all these and keep only one. So, here we are having certain terms are repeating, take only one term. So, a bar b bar c plus a b c bar plus a bar b c plus a b bar c, a b bar c, because a b bar c bar, a b bar c bar is repeating twice. Okay, sorry, a b c bar is repeating twice. You have to take only one times and you will be getting the canonical form. Similarly, the another one where it is a POS form. Here also this is not in the standard canonical form, because the a is missing in the second term, b is missing in the third term. So, here what you have to do is add an a bar where a is missing. Okay. So, adding a 0 will not change the value, a bar is 0. So, you have to add a in the second term, b in the third term, and then expand. Finally, you will be getting the standard canonical form. So, if a term or an expression is given in non-canonical form or standard form, you can convert into the canonical form for either in SOP or in POS. That is all.